From a lonely farm in rural England, a curious boy grew into the greatest scientific genius the world has ever known. This is the full story of Sir Isaac Newton, the man who unlocked gravity, invented calculus, revolutionized optics, tangled with rival scientists, and forever changed how we see the universe. In 8 dramatic chapters, we'll dive into Newton's early life, his struggle with isolation, his greatest works and controversies, and the enduring legacy of his mind. Prepare for jaw-dropping revelations, dark twists, and a portrait of a human genius deeper than any myth. Isaac Newton was born prematurely on Christmas Day, 1642, in the quiet village of Woolsthorpe, England. He was so tiny and weak that his family didn't expect him to survive the night. England was in chaos, civil war raged, and science was still shackled to medieval dogma. Yet within this fragile child was a mind that would shake the foundations of everything we thought we knew about the universe. Newton's childhood was marked by abandonment and emotional scars. His father died before he was born, and his mother left him to be raised by his grandmother when she remarried. These experiences fostered a deep loneliness and intense self-reliance. Young Isaac wasn't sociable, but he was endlessly curious. He built sundials, windmills, even mechanical dolls. To him, the world wasn't just a place to live. It was a puzzle waiting to be solved. As a student at Cambridge, Newton was distant and reclusive, more interested in ancient texts and secret notebooks than lectures. But history pivoted in 1665, when the Great Plague forced the university to shut down. Newton returned to Woolsthorpe alone, a retreat that would become the most productive isolation in scientific history. He later called it his Annus Mirabilis, his year of miracles. During this solitude, the mythic apple supposedly fell. While the tale has been dramatized, the idea it symbolizes is real. Newton observed an apple falling and began to question whether the same invisible force pulling it down might also reach the moon. What if gravity wasn't just an earthly phenomenon, but a universal law? That single question sparked a revolution. Newton didn't just speculate, he calculated. Using tools no one else had, tools he invented like calculus, he began building a framework that explained the movements of planets and the fall of apples alike. But Newton was cautious. His ideas were radical. He kept them private, testing and refining his theories in silence. This moment didn't yet define Newton's legacy, but it planted the seed. The mind that connected the apple to the cosmos had taken its first step toward changing the universe forever. The plague that swept across England in 1665 forced Cambridge University to close its doors. Most students saw this as an interruption to their education. Isaac Newton saw it as liberation. He returned to his family estate in Woolsthorpe, and there, in isolation, with no professors, no distractions, and no limitations, he experienced one of the most extraordinary creative explosions in scientific history. This wasn't just a productive phase, it was the ignition of a genius unchained. Newton, still in his early 20s, began working on problems that had stumped humanity for centuries. He experimented with prisms and light, discovering that white light is composed of all the colors of the spectrum. He laid the groundwork for calculus, scribbling equations in the margins of old books. And he refined his theory of gravity, not just as a force that caused apples to fall, but as a universal phenomenon that shaped the very cosmos. He worked obsessively, often forgetting to eat or sleep. Woolsthorpe became both laboratory and sanctuary. Newton used a needle to prod his own eye just to test how light bent inside it, a horrifying experiment that revealed his commitment to uncovering nature's secrets by any means necessary. The risks were great, but the rewards were monumental. In the silence of his rural home, Newton also invented the foundations of what would later be called Newtonian mechanics. He wrote out principles that governed motion, inertia, and acceleration, concepts that no scientist before him had fully grasped. Alone, without collaboration or oversight, he constructed the scaffolding of modern physics from the ground up. He kept his notes hidden. Newton feared ridicule. His mind was turbulent, equally brilliant and paranoid. But even as he doubted himself, the intellectual storm raging inside him continued to forge tools that would one day reframe all of science. By the time Newton returned to Cambridge, he was not the same man who had left. He carried within him the beginnings of a new universe, not yet revealed to the world, but already reshaping it from the inside out. By the time Isaac Newton returned to Cambridge after the plague years, he had already cracked open the doors to an entirely new mathematical realm, calculus. While the term hadn't been coined yet, Newton had developed the foundational principles, the ability to measure change, model curves, and understand motion in a way no previous mathematician had. He called it fluxions, a system that would later be recognized as one of the most powerful mathematical tools in history. Why was this revolutionary? Because it allowed scientists to describe things that were previously unmeasurable. The speed of a falling object at any given moment, the area under a curve, or the rate at which something was changing. In essence, Newton invented the language of motion. Without it, physics as we know it today could not exist. But Newton didn't publish it, not yet. The shadow of doubt still lingered. His notebooks from this period read like the mind of a man possessed. Pages filled with infinite series, binomial expansions, and elegant manipulations of algebraic expressions. His use of mathematical abstraction was unprecedented. Where others saw disconnected problems, Newton saw patterns, symmetry and chaos, rules beneath disorder. He was connecting the dots between geometry and algebra in ways no one had done before. But there was tension brewing. Across Europe, another great mind, Gottfried Wilhelm Leibniz, was developing a remarkably similar system of calculus. The seeds of one of the greatest intellectual disputes in history were quietly being planted. The Newton-Leibniz controversy would eventually engulf the scientific world, with national pride and personal ego at stake. At the time, though, Newton remained silent. He believed in divine truth and feared premature exposure of his ideas. To him, mathematics wasn't just a tool. It was a path to understanding the divine architecture of the universe. He saw himself not merely as a scientist, but as an interpreter of cosmic laws written by the hand of God. And so, he waited. The world wasn't ready for what he had discovered. But deep in his study, Newton continued building an invisible cathedral of logic and numbers, a structure that would soon prove unshakable. In the quiet shadows of his Cambridge quarters, Newton turned his attention to a different mystery: light. Using a simple glass prism, he conducted a series of experiments that would forever change the way humanity understood vision, color, and optics. He passed a beam of sunlight through the prism and observed it split into a spectrum: red, orange, yellow, green, blue, indigo, violet. This wasn't just pretty, it was profound. The common belief at the time was that white light was pure and colors were added by the prism. Newton proved the opposite. White light is a combination of all colors, and the prism simply separates what was already there. This realization shattered centuries of misconceptions. With a second prism, he even recombined the spectrum back into white light, closing the loop and confirming the truth. It was elegant, empirical, and irrefutable. Newton's obsession didn't stop at theory. He hated the chromatic distortions of existing telescopes, so he built his own, the first practical reflecting telescope. By using mirrors instead of lenses, He eliminated the rainbow halos that plagued refracting telescopes. This wasn't just an academic exercise. It was a breakthrough in astronomy, and it won him entry into the prestigious Royal Society. But with acclaim came conflict. Robert Hooke, a senior member of the Society, took issue with Newton's work. Hooke claimed that Newton's ideas were not entirely original and publicly criticized him. The conflict escalated quickly. Newton, ever sensitive to criticism, withdrew from the scientific community for years. He buried himself in study, vowing to never publish again. The feud with Hooke would haunt him for decades. Yet even in seclusion, Newton's fire didn't fade. He continued refining his theories of optics and perception, exploring how the eye and brain processed visual information. He even developed a theory of color based on particle behavior, centuries ahead of modern neuroscience. The prism revealed more than the spectrum. It exposed Newton's nature, relentless, revolutionary, and deeply reactive. Light, for him, wasn't just a scientific subject. It was a gateway to uncovering invisible laws and a battleground for his pride. The silence that followed Newton's withdrawal from public debate was deceptive. Behind the scenes, he was crafting the single most influential scientific work ever written, Philosophia Naturalis Principia Mathematica, known simply as the Principia. It would become the foundation of classical physics and the framework for how we understand motion and force to this day. Newton didn't plan to publish it. It took the intervention of astronomer Edmund Halley, who visited Newton in 1684 and asked a simple question: why do planets move in elliptical orbits? Newton casually replied that he had already solved it. When pressed for proof, he sent Halley a 9-page derivation. Halley was stunned. He urged Newton to write a full treatise, and even paid for its publication when the Royal Society ran out of funds. Published in 1687, Principia introduced the world to Newton's 3 laws of motion: inertia, acceleration proportional to force, and action-reaction. Simple in form, they revolutionized physics. More profoundly, he formulated the law of universal gravitation, the idea that every object in the universe attracts every other with a force proportional to their masses, and inversely proportional to the square of the distance between them. What made Principia more than a scientific paper was its method. Newton married mathematical rigor with physical observation. He turned celestial phenomena into equations, uniting the heavens and earth under one system. For the first time in history, the universe could be predicted, measured, and modeled. But Principia wasn't universally loved. Critics found it dense and abstract. Some rejected its implications. Hooke accused Newton of stealing ideas, reigniting their feud. Others were simply overwhelmed. Yet, over time, the brilliance of the work became undeniable. Newton hadn't just solved problems. He'd changed the very rules of how to think about them. With the publication of Principia, Newton went from secretive recluse to scientific titan. He had distilled the motion of the cosmos into 3 simple laws, and in doing so, gave humanity a tool that would guide physics for the next 3 centuries. Behind Newton's towering intellect was a man consumed by insecurity, rivalry, and an almost pathological need for control. The brilliance of his discoveries was matched only by the darkness of his feuds. As his fame grew, so did his list of enemies. Chief among them, Robert Hooke and Gottfried Wilhelm Leibniz. The battle with Hooke was personal. Hooke, already a respected member of the Royal Society, accused Newton of stealing ideas on optics and gravitation. Newton, incensed, dismissed Hooke's criticisms as envy. Their correspondence turned bitter. Newton even refused to include Hooke's name in future editions of Principia. Some say he waited to become president of the Royal Society just so he could remove Hooke's portrait from its walls. a final, silent revenge. Then came the Continental War with Leibniz. Both men had developed calculus independently, but when Leibniz published first, Newton's allies accused him of plagiarism. What began as a scholarly debate soon devolved into nationalistic mudslinging. Newton orchestrated an anonymous review that condemned Leibniz, a review Newton himself had written. He turned science into strategy, determined not just to win, but to erase rivals from history. These weren't just ego clashes. Newton's emotional volatility ran deep. He experienced breakdowns, long periods of isolation, and intense paranoia. He kept meticulous records, held grudges, and obsessed over theological codes in the Bible. His genius didn't insulate him from turmoil. It amplified it. The same mind that could model the universe also spiraled into self-inflicted torment. Yet through this turbulence, Newton amassed extraordinary power. He became warden of the mint, overseeing England's currency. He hunted counterfeiters with ruthless efficiency, personally interrogating and prosecuting criminals. His transformation from scholar to state official revealed his hunger for dominance, not just over ideas, but over people. Newton's rivalries left a trail of shattered relationships and suppressed voices, but they also fueled his obsession with perfection. He wasn't just defending his discoveries, he was defending an identity. For Newton, being right wasn't enough. He had to be the last man standing. In his later years, Isaac Newton drifted further from the public image of the rational scientist and deeper into the esoteric corners of thought. While the world celebrated his laws of motion and universal gravitation, Newton immersed himself in the study of alchemy and theology, pursuits he kept largely secret. To him, these weren't separate from science, but complementary paths to uncovering divine truth. Newton believed that God's fingerprints were hidden not just in the stars, but in scripture, ancient texts, and even the composition of metals. He devoted more time to decoding biblical prophecies and searching for hidden messages in the book of Revelation than he did to physics. In the shadows of candlelight, he pored over ancient manuscripts and alchemical formulas, convinced that knowledge of the material and spiritual worlds were intertwined. His work in alchemy was extensive. He wrote over 1 million words on the subject, far more than on physics or math. Newton believed that matter could be transmuted, not only physically but spiritually. To the modern mind, this may sound like superstition, but to Newton, alchemy was the key to understanding creation itself. He wasn't chasing gold, he was chasing God. His theological writings reveal a complex faith. Newton rejected the Trinity, a stance considered heretical. He saw Christ as divine but subordinate to God, a belief he hid to avoid excommunication. He believed the Bible held mathematical codes that could predict the end of days. These views didn't diminish his logic, they expanded his framework of inquiry. He sought ultimate truths, no matter how buried or blasphemous. As president of the Royal Society and master of the Mint, Newton remained a figure of public order and respectability, but privately he remained restless. His mind was never still. He oscillated between reason and revelation, between equations and prophecy. Even in old age, the engine of his intellect never stopped turning. Newton's final years were not a quiet fade into history, but a descent into deeper mysteries. To some, he was the founder of modern science. To himself, he was something more, a seeker of the eternal laws behind all existence. Isaac Newton died in 1727, but his ideas never did. His grave in Westminster Abbey marks the resting place of a man, but not the end of his influence. The legacy he left behind stretches across time, shaping every rocket launched, every bridge built, every equation written to describe the physical world. Newton didn't just explain how objects move. He redefined what it meant to understand reality. The Principia became a scientific cornerstone studied by scholars for generations. His laws of motion and gravity were used to send humans to the moon, guide satellites, and build machines of all kinds. When Einstein developed his theory of relativity, he stood not in opposition to Newton, but on his shoulders, expanding the frame Newton had built, never dismantling it. Even in the face of quantum physics and cosmic uncertainty, Newtonian mechanics remains the bedrock of classical science. But Newton's influence extends beyond science. His life became a model of obsessive dedication, of what one mind can achieve in isolation. He proved that the pursuit of truth, even when tangled in ego, conflict, and obsession, could reshape the destiny of civilization. He showed that the universe wasn't chaos, but code, and he decoded it. His name entered the cultural lexicon. Newtonian became a synonym for order and predictability. Schools, theories, and even Apple-branded metaphors were built in his name. Yet the true Newton was far more complex than the myth. A man of light and shadow, genius and fury, reason and faith. Centuries later, we still teach Newton's laws to children. We launch spacecraft using his equations. His reflections on time, force, and gravity remain the blueprint for how we move through space, both physically and intellectually. Newton didn't just change science, he changed how we think. In the end, the boy who watched an apple fall didn't just discover gravity, he redefined humanity's place in the cosmos. And if you've ever wondered why the planets move, or how the stars shine, or what keeps your feet on the ground, you're still living in Newton's universe.